Sumerian tablets are probably one of the oldest form of written record that we have.
What if the oldest written warning in human history was never meant to survive, but somehow did? Hidden behind glass in the British Museum sits a tiny clay disc that has left scientists completely shaken. At first glance, it looks like just another ancient Sumerian artifact. But when experts finally decoded the strange markings carved into its surface, they realized this was not mythology, religion, or poetry. It was a sky map, a detailed record of something terrifying that crossed the heavens thousands of years before the rise of civilization itself. And here's where the story becomes deeply unsettling. The stars etched into the tablet do not match the skies of the Sumerians. They match a much older night sky, one dating back to a forgotten era before the first cities, before kingdoms, before history officially began. 8 precise measurements carved into the clay appear to track the movement of an object racing across the sky. Researchers now believe someone witnessed a catastrophic celestial event and desperately tried to preserve the warning for future generations. So before we expose what scientists say this ancient star map may have predicted, hit like and subscribe, because some believe history's oldest secrets were never meant to be uncovered. The disc that should not exist. The artifact has a quiet British Museum catalogue number, K.8538. You can walk past it in room 55 and never know what you are looking at. Roughly 14 centimeters across, small enough to hold in one hand, one side carved into 8 wedge-shaped segments, like a pie chart pressed into wet clay nearly 3,000 years ago. Most cuneiform tablets from this era beg the gods for harvests, kings, or favorable wars. This one does something else. It measures star positions, logged against known constellations, angular data of the kind a navigator would use, rising and setting times given to a precision that serves no ritual purpose at all. Buried in several segments are numerical sequences that describe not just where something is in the sky, but where it is going, at what angle, and at what speed. It reads like an instrument log, a flight recorder pressed into mud. Henry Layard pulled it out of the ground in the 1850s. Picture him there for a moment. A Victorian Englishman in heavy wool, standing knee-deep in the dust of Nineveh in the heat of an Iraqi summer, surrounded by trenches and broken brick, while local workers hauled tablets out of collapsed shelving by the thousand. Most went into crates. Most were never read. This one made it into the case in London, and there it has remained while the world walked past. Sir Austin Henry Layard, born in the year 1817, was in northern Iraq, where he helped to uncover the ancient Assyrian cities of Nineveh and Nimrud. There were found relics and statues of bulls and lions and thousands of clay tablets inscribed in the language of cuneiform, the night that predates. Writing, the clay, dates to roughly 700 BCE, the height of the Assyrian Empire under King Ashurbanipal. But here is the problem. The clay is one age. The data carved into it is something else entirely. Modern astronomy software can rewind the heavens. Stars drift slowly but predictably, century by century, through a wobble called precession. Feed enough star positions into the right program, and the program will tell you, to the night, when that exact sky existed. It is the kind of thing professional astronomers use to plan observations, and historians use to date eclipses in old chronicles. So somebody fed the planisphere into one. The configuration on the tablet does not match 700 BCE. It does not match 1000 BCE, or 1500 BCE, or 2000 BCE. The match the software returned was a specific night, roughly 2,400 years before the tablet itself was even shaped. The date is June 29th, 3123 BCE. Nobody should have that data. Think about what that means for a second. That is older than the oldest Sumerian city we have any written record of. It is older than cuneiform. It is older than writing in any form at all. Whoever made the original observation was watching the sky in a world before the first ledger, before the first king list, before the first scribe ever pressed a reed into mud and called it language. And yet, someone standing somewhere on the plain between two rivers recorded that exact summer night with enough accuracy that more than 5,000 years later, a laptop could match it to within hours. Picture them. A figure on a rooftop or a riverbank in the pre-dawn dark. No telescope, no paper. Some scratch marks on bone, clay, or wood we no longer have. Watching something cross the sky that was important enough to write down in a world that did not yet know how to write. What were they looking at? The two men who read it like engineers, 2008, London. Two researchers named Alan Bond and Mark Hempsel published a book arguing they finally knew. Bond is an aerospace engineer, grey-haired, quiet, the kind of man who has spent a working life inside the dense mathematics of rocket propulsion, putting decades into engine designs for spacecraft. Hempsel is a spacecraft systems engineer who has worked with the European Space Agency. They are not Assyriologists. They are not classicists. They are men who, for a living, read trajectory data the way you read a road sign. When the planisphere lands in front of them, they do not see religion. They do not see omen literature. They see a worksheet. Hempsel later described the moment of recognition. Alan knew that I enjoyed this sort of hobby project as much as he did, and further, my research at the university at the time was looking at global catastrophe events. So he asked if I would be interested in joining him, and of course I said yes, please. The two of them, sitting with photographs and a translation of the cuneiform, worked through the segments one at a time, the way you work through any technical document. And somewhere in the second or third segment, the pattern resolved. The numbers stopped being abstract. They started describing motion. A single object, observed 8 times, plotted against the fixed stars as it moved across the sky. The shape of the data is unmistakable to anyone who has spent their career staring at it. Bond, the older of the two, the man whose working life has been rocket motors and orbital mechanics, said the obvious thing. This is not astrology. This is tracking. What Bond and Hempsel saw. What Bond and Hempsel saw, the moment they understood the structure of the 8 segments, was not a star map in the religious sense at all. It was a tracking log. A single moving body, observed at 8 separate moments, plotted against the fixed stars as it crossed the sky. The kind of record you produce when you are watching something that does not belong up there. And once you have 8 points, you can draw a line. Think about what that means for a moment. 2 engineers working in the 21st century looked at a disk made before the rise of Rome and recognized the mathematics because they used that same mathematics to put rockets into orbit. So they did what any engineer would do. They projected the line forward. The trajectory points somewhere specific. The path begins high. The object enters the atmosphere at a shallow angle, the kind of approach that produces a long, slow, glowing streak rather than a sudden flash. It crosses the eastern Mediterranean, still riding high. It passes the northern coastlines and continues inland, descending the whole way, slow enough to be tracked, bright enough to read by, visible from horizon to horizon for anyone awake and looking up. Picture it from the rooftop of a mud brick settlement on the Tigris flood plain. A line of fire crawling across the pre-dawn sky, west to northwest, brighter than the moon, slow enough that you could mark its position against the stars, run inside, come back out, and mark it again. That is the kind of object the planisphere is describing. Not a meteor. Meteors flash and vanish in a heartbeat. This thing was up there long enough to be measured, 8 times, and then the numbers run out. Wherever the line ends is where the object either struck the ground or exploded in the air above it. The line ends in the Austrian Alps, more specifically, in a narrow valley in the Austrian Tyrol called Kufels. You have probably never heard of Kufels. There are no tourist signs, no streaming documentaries. But here is the problem. Kufels is the site of one of the largest prehistoric landslides in all of Europe, possibly the largest in the entire Alps. Roughly 9 cubic kilometers of mountain came apart in a single event and filled the valley floor. Take every high-rise in Manhattan, crush them into rubble, and you would have a fraction of a percent of the material involved. Geologists have studied that deposit for over a century. They have dated it, they have argued about it, and on one fundamental point, they have never agreed. Nobody can explain what caused it. The mountain that came apart. And the question nobody wants to ask. Normal landslide mechanics break down at Kufels. The volume is too large for ordinary slope failure. There is no clean seismic fault running through the area. Groundwater saturation, the usual culprit in smaller collapses, does not scale to 9 cubic kilometers of rock shearing off a mountain in a single episode. And then there is the melted rock. Scattered through the Kufels deposit are pieces of stone that were heated during the event to temperatures high enough to partially liquefy them, before cooling back into deformed shapes. The existence of this material is not in dispute. Its cause is. Some specialists argue that friction from the moving rock could have done it. Others argue that friction alone cannot account for the specific mineralogy, and that something else, something hotter and faster, was involved. That something else is an airburst, a detonation in the sky above the valley, a pressure wave combined with a thermal pulse, powerful enough to destabilize the slope and hot enough to glaze stone. You already know the modern reference point. Tunguska, Siberia, 1908. An incoming object exploded in the atmosphere and flattened roughly 800 square miles of forest without leaving a crater. Trees laid down like matchsticks, all of them pointing away from a single empty spot in the sky. No fragments to recover. Just devastation, with nothing in the middle of it. Kufels, if the airburst model is right, would have been larger, possibly significantly larger. The kind of event that does not just flatten a forest. The kind of event that takes a mountain off the map. And the line drawn by 2 aerospace engineers, projected forward from a clay disk copied in the Assyrian library and originally observed in a world before Sumer, ends precisely there. But here is the problem. If the trajectory ends at Kufels, then somebody had to be alive to watch the object that caused it, and that somebody was not Assyrian, not Babylonian, not even Sumerian in the strict sense. They lived before all of it. A copy of a copy of a copy. If Bond and Hempsel are right, the tablet in room 55 is not an original observation. It is the last surviving link in a chain. Imagine the chain. June 29th, 3123 BCE. A figure stands on the plain between the Tigris and the Euphrates in the dark hour before dawn. Cuneiform does not exist yet. The Sumerian city-states have not been founded. The wheel is barely a rumor. Whatever they use to record the moment is some pre-literate medium. Tokens, scratches, paint on bone. The kind of artifact that does not survive to be excavated. Their name is gone. Their face is gone. What they recorded is not. That figure watches a long, slow streak of light cross the sky from one horizon toward the other. They mark its position 8 times. They calculate in whatever proto-mathematics they have where it is going. Then the light reaches the Alps, and the world shudders. The record is preserved. Generations later, someone in the early Sumerian period translates it into proto-cuneiform. Generations after that, someone copies the cuneiform forward. The Sumerian city-states rise and fall. The Akkadian Empire rises and collapses. The Babylonians replace them. The Assyrians replace the Babylonians. Languages reform. Scripts are abandoned and rewritten. Empires burn each other's libraries down. And through all of it, this one specific observation log keeps getting copied. Sumerian scribes pass it to Akkadian scribes. Akkadian scribes pass it to Babylonian scribes. Babylonian scribes pass it to Assyrian scribes. None of them, almost certainly, knew exactly what they were carrying. They only knew, generation after generation, that this particular record was not allowed to be lost. That is not an accident. Ashurbanipal, the king who ultimately gave the tablet its final home, did not assemble his library by chance. He sent agents across the ancient Near East with explicit instructions to bring back the oldest, rarest, and most significant texts they could find. The library at Nineveh was a deliberate act of civilizational memory. It was the place where Mesopotamia kept what Mesopotamia could not afford to forget. And Ashurbanipal's curators kept this. A small clay disk from a sky no living person had seen, copied from a Sumerian-era observation that itself copied something older still. Why? Why preserve a record that long? The obvious answer is the only honest one. The library at Nineveh was a copying factory. Ashurbanipal, who built it, was collecting tablets from all over the Assyrian Empire and having them copied. The event being described was the kind of thing a civilization does not forget. It gets witnessed, it gets recorded, it gets copied, generation after generation, because forgetting it would feel like a kind of betrayal of the people who saw it. The silence from the experts. Bond and Hempsel's book was published by a small academic press with a peer review process. Their methodology is laid out on the page. The star position calculations, the dating, the trajectory reconstruction, all of it is open to checking. You do not have to take their word. You can take their numbers, plug them into a free planetarium program, and watch the match light up on your screen. So, what happened next? Nothing. That is what happened. The academic response was not a rebuttal. It was a shrug. The book got described in passing as speculative, as fringe, as the kind of thing serious Assyriology does not need to engage with. But here is the problem. Nobody published a counter-calculation showing that the star positions match a different date. Nobody published an alternative trajectory analysis showing that Bond and Hempsel drew the wrong line through the data. Nobody published a better explanation for the Kufal's landslide that accounts for the volume, the melted rock, and the geology more convincingly than an airburst. Bond went back to his rocket engines. Hempsel went back to his spacecraft systems. The book stayed on the shelf, where it has stayed for nearly 2 decades. And in the years since, the question has not gotten smaller. It has gotten larger. Because every additional year of academic silence is another year in which nobody has been willing to actually do the work. The argument was not answered. It was ignored. there is a difference, and the difference matters. Science moves forward by refuting specific claims with specific evidence, not by deciding in advance which claims are respectable enough to merit a response. Dismissal by label is not the same thing as disproof by analysis. The planisphere is still in room 55. The landslide is still in the Tyrol. The date, June 29th, 3123 BCE, is still the only specific answer anyone has produced to the question of what the tablet is recording. And the question of what an unknown observer watched cross the pre-Sumerian sky on that specific morning is still open. But the trajectory still points to Kofels. And that is where the real problem begins. When you step back and look at the evidence as a whole, the story becomes difficult to ignore. Two aerospace engineers took an ancient Mesopotamian star disk and traced a path from the sky onto a modern map. That path ended in a remote valley where an entire mountainside once collapsed in a way geologists still struggle to fully explain. The shattered rock is real. The massive debris field, nearly 9 cubic kilometers of displaced material, is real. The astronomical alignment pointing back to 3123 BCE is real. And the fact that this strange record was carefully copied and preserved for thousands of years by the scribes of Ashurbanipal is also very real. One of the researchers later admitted the findings felt too important to stay hidden. He explained that the results were so convincing, he pushed hard to make them public, even though his co-author usually kept projects like this private. Individually, each detail sounds like an interesting historical mystery, but together, they form a pattern that is hard to dismiss. The ancient planisphere of Nineveh appears to contain star data describing a night sky from before writing officially existed. Somehow, that information survived through generations of Akkadians, Babylonians, and Assyrians until it was stored in one of the most important libraries of the ancient world. When modern engineers analyzed the markings using astronomical calculations, they concluded the tablet described a tracked object moving across the sky on a measurable path. That projected path leads directly toward a region where a catastrophic geological event occurred around the same time, with no universally accepted explanation for why it happened. That does not automatically prove an asteroid impact occurred, but it does create a question that deserves serious investigation. In most scientific fields, a pattern this strong would spark major follow-up studies. Instead, the theory has mostly been pushed aside without a full public re-examination, and that leads to one unsettling possibility rarely mentioned in documentaries or textbooks. This tablet may represent the only surviving eyewitness account of a catastrophic asteroid event in human history. Maybe that conclusion is correct. Maybe it is not. The only way to know would be for modern astronomers and independent researchers to rerun the calculations openly, verify the data, and see exactly where the theory holds up or falls apart. Surprisingly, that kind of large-scale public analysis has never truly happened. Today, the tablet still rests quietly inside the British Museum. The books discussing the theory still sit on library shelves. The software needed to test the calculations can run on an ordinary laptop. In theory, a determined researcher could reopen the entire mystery at any time, and that is what makes this story so haunting. The people who first recorded the event are gone. The ancient kingdoms that copied the tablet are gone. The kings, scribes, and archaeologists connected to its discovery are all part of history now, but the artifact remains. The valley remains. The unexplained line connecting the two remains, and the question of what crossed the sky before dawn on June 29th, 3123 BCE still has no final answer.